of us. So it's fantastic, and I'd like to now officially welcome everyone to our very first online discussion of the year. We had many last year, which was a great evolution of Wisaarkhu and where we've come. My name, you can probably see it there under my face. It is Sean Hudson Bennett, and I'm a maths teacher at Somerset College, at Somerset West in South Africa, just outside of Cape Town. So I have been involved with Wisaarkhu for about a year, and it is the most wonderful place where you have maths evolving with psychology of people and philosophy, and it's a fantastic platform that has evolved a lot, bringing in perspectives from last year from around the world. So just to let you know, we have people from all over South Africa, from all over India as well, Zimbabwe, Tanzania, people have registered from Nigeria, Slovakia, the Philippines, Brazil, Tunisia, Australia, as well as United States of America. You can see that image behind Dr. Randy Palisoc. This is going to be just a very relaxed, casual environment. No need to worry or stress. You're very free to engage and have discussions in the part of the hour remaining after Dr. Randy Palisoc has finished his 10-minute or so presentation. So we'd like you to use the chat. And if you would, just to guide us through it, if you've got a contribution to make, everybody is free and welcome. And when one person is speaking, if you don't mind just switching off your microphone and your camera as well, just so that we focused in on the one person. And then we would love to see your face as you have a question or if you want to speak. But no, if you don't want to, it's completely up to you. Okay, so I'd like to introduce Dr. Randy Palisoc. He started in his previous life, believe it or not, as a businessman. But after a short time, he thankfully saw the light and he saw a better option of education, and thankfully for us as well. So he got his degree in education, and then he got his master's in education, and then he teamed up with his wife to get his doctorate with his wife in education. And then in 2004, Dr. Palisoc and Dr. Palisoc opened up a school together called Synergy Academies. So this school has achieved tremendous success. 7 national awards, best urban elementary school in America in 2013. And a big reason for the success is because Dr. Randy Palisoc, I'm going to call you Randy if you don't mind. And he rewrote the curriculum in order to be more understandable and make sense to children. So he then took this idea and this concept later and began an initiative to focus on developing the curriculum to make it more accessible to more schools. So he designed Core Advantage Math Fluency System, and that reaches many more students, teachers, parents with lesson-by-lesson demo videos. He provides professional development and parent workshops. Randy's message of making maths easy has been shared as a TEDx talk, which has been viewed by millions. He currently teaches at James Jordan Middle School, but he's had experience in education with elementary school and middle school, as well as high school and college levels. So it brings me great joy to welcome and to hand over to Randy Palisoc.
Thank you, Sean. Thank you for the wonderful introduction. Hello, everyone. It's a pleasure meeting all of you. I am calling in from the United States today. So let me go ahead and turn on the presentation. Here we go. And this presentation is called Humanizing the Math Experience. And to recap the wonderful introduction that Sean gave, I am Dr. Randy Palisoc. I have been in education for 23 years at the elementary, middle school, high school, and at the college levels. And I am one of the founders of Synergy Academies, which is a nonprofit that runs 3 schools in South Los Angeles. One is an elementary school, a middle school, and a high school. And after running the schools for 10 years, I decided to leave the schools that we started to go into curriculum design, because I noticed that with the textbooks that we were using with our students, it was written in a way that didn't really make sense to the kids. So we did have to end up rewriting a lot of the lessons to make them more accessible to students. So I decided to leave the school that we started to go into curriculum design and publish all the lessons that we have been created, that we had created at our schools. So I've written a series of 10 math fluency books under the Core Advantage name. And I'm also a professional development specialist. And yes, I am currently a 6th grade teacher at James Jordan Middle School. So that's a little bit about myself, and I'd like to get to know you as well. So would you kindly open up the chat window, and in the chat window, type your name. I think it actually already appears. Type in what part of the world you're calling in from and your role in education or whatever field you are in. So go ahead and take a minute to type in the chat now. And let me go check out the chat. All right, welcome Colleen, Annaline, welcome. Kathleen and Sophie. Great, someone's been teaching for 30 years. Great, we have a psychologist in the house. Welcome, welcome. So go ahead and continue to do that because I'd love to get to know you. And let me put the presentation back up. All right, so this session again is entitled Humanizing the Math Experience. And here are some questions for you to ponder. Number one, why is there such a huge stigma around mathematics? Number two, why do people label themselves as either a math person or not a math person? And number three, which is the most important question that we need to answer today, is why are there so many memes like this floating around the internet? So this is one of my favorites. This is the confused math meme. So here we go. So that's one of the famous memes that's out there, and it really captures how a lot of people are confused about math. And whenever there's an online discussion, even if it's not related to math, people love to use this meme. And another one of my favorites, I hope the sound came through for you there. Did it come through for you, Sean?
Yes, we heard it.
Perfect.
Good old X-Files theme. We know that well.
That's what makes this one of my favorites. And another one of my favorites is this one here. I remember watching this when I was in high school. This is from The Simpsons episode 1, or season 1, episode 2. And it first aired January 14, 1990. So over 30 years ago. And this is when Bart cheated on an exam and got placed into a school for the highly gifted. So here's the example.
So y equals r cubed over 3. And if you determine the rate of change in this curve correctly, I think you will be pleasantly surprised. Oh! Well, don't you get it, Bart? Derivative dy equals 3r squared dr over 3, or r squared dr, or r drr. Hardy har har. Get it?
Oh, yeah.
So poor Bart is in this classroom, and these elementary school kids are learning calculus, and he's completely out of place. And that look on his face.
So y equals r cubed over 3.
That look on his face when everyone gets the joke and he doesn't, that was actually me in college calculus. So I don't know about you, but I never took calculus in high school. It wasn't offered at the school that I was attending. So when I entered college, I was required to take a calculus class as part of my business major. And when I signed up, I thought, okay, they'll probably take it easy on us because we're business majors, we're not math majors, and we'll get an easier version of calculus, and which I was looking forward to because I'd never taken it in high school. And it turns out that was far from the truth. You actually needed to already know calculus in this class, and they were just using applications of it in the business world. So that was me in college calculus, and that was the worst semester of my life. And as soon as I failed my first test, I had to think of explanations that I was going to give to my parents about why I dropped out of college and didn't even make it past one semester. So I did end up passing the class, and I learned how to get the answers. But even after leaving the class, I still had no clue what calculus was. So that confused look, I think a lot of students feel that way about math, and not just older kids about calculus, but kids in general about math in general. And there's this huge stigma about mathematics, and a lot of kids feel like they don't belong. And during this session, I want to explore why that's so and what we can do about it. So in my opinion, one of the reasons I think there's a stigma around mathematics and why people feel like they're not math people is we've been teaching it as a dehumanized subject. And the question is, how have we dehumanized math? And my answer to that is that we've forgotten that math is a human language, just like English, Spanish, or Mandarin Chinese, because it allows people to communicate with each other about the real world around them. And in fact, a famous philosopher by the name of Galileo once said that the laws of nature are written in the language of mathematics. But somehow we've taken this language of math and have abstracted it far beyond recognition, and that's why a lot of kids are so confused. And to give you an example of that, this is a 3rd grade standard here in California where I teach, and it says, understand a fraction 1 over b as a quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction a over b as a quantity formed by a parts of size 1 over b. And if you gave this explanation to an 8-year-old, this is probably the reaction that you would get from them. And to a math expert, this explanation makes perfect sense, but if we approach it this way with our students, it'll make absolutely no sense to them and will only cause confusion and frustration. So the question is, how can we teach concepts like fractions to students, but in a simple way that actually makes sense to them? And the challenge that I want to look at first is a 5th grade challenge. The challenge is how to add and subtract fractions with unlike denominators, which on a scale of 1 to 10 makes how much sense to students? 0. It makes absolutely no sense to them. And the reason this doesn't make sense to students is because they don't know about numerators and denominators, but they do know about apples and apples. So start there instead. So when I'm teaching 5th graders about adding and subtracting fractions with unlike denominators, I always start with the apples plus apple lesson, which here's an example of it. And we start off with 1 apple plus 1 apple. And a lot of times students will respond as 2 with the answer to this problem. And it's partially correct. So we should remember that math is a language. It's a human language, so we should include the words in it as well. So it's not just 2. Insist that the students respond as 2 apples. So here's the next one. What is 3 pencils, 2 pencils plus 3 pencils? And you all know that pencils plus pencils give you pencils. How many pencils? We have 5 pencils. Things get a little interesting when we get to box C. So here the question is, what is 3 pencils plus 2 cars? And students will look at this problem and say, Dr. Palisoc, that doesn't make any sense because pencils and cars aren't the same thing. How do you add them together? So I tell the kids that they're exactly right, that it doesn't make any sense, so we cannot add them together. In order to add things together, they have to have the same name, like apples and apples or pencils and pencils. So attempting to add pencils and cars makes absolutely no sense. So we cross it off during the lesson. Then in the next word, we get to those confusing fractions problems. But to clear students' minds, we spell it out in words like this. What's 1/3 plus 1/3? And when you present it this way, now students can use apples plus apples as their analogy. Realize that thirds plus thirds give you thirds, and the total here is 2/3. And notice how much more effortless that is. Things get interesting again in box F. So they're presented with 1/2 plus 1/3. And again, students look at that problem and say, Dr. Palisoc, halves and thirds aren't the same thing. We cannot add them together. So of course, we cross it off. Now when you take these same two fractions problems and write them in fraction notation, the logic makes a lot more sense. So in box G, instead of spelling out 1/3 plus 1/3, we write it like this: 1/3 plus 1/3. And the logic is still there. So just like apples plus apples give you apples, thirds plus thirds still give you thirds. How many thirds? 2/3. And students are able to arrive at the sum without having to understand what a numerator and denominator is. And now imagine what happens when we get to box I and students see this. Here's 1/2 plus 1/3. Again, they'll say, Dr. Palisoc, halves and thirds are not the same thing. We cannot add them together. And I say, exactly. So we cross off this problem. And you might be wondering, how do students know that you can't just automatically add them together when they don't know about numerators and denominators? Well, they're not using numerators and denominators. They're using their intuition instead, which is a lot more powerful than any rule that you can come up with. The last row is the most important row. So in box J, we have the problem 1 apple plus 1 banana. And of course, we know that this makes absolutely no sense because apples and bananas are not the same thing. They don't have the same name, so you cannot add them together. So we cross off that problem. But in box K, we put that very same problem on screen. And I explained to the students, 1 apple plus 1 banana, I know we can't add them together because they're not the same thing. But what if you had to find a way to make it work? And without fail, someone in the class will say, Dr. Palisoc, they're both fruits. And I say, exactly. So why don't we rename them? Instead of 1 apple plus 1 banana, let's call them 1 fruit and 1 fruit. And now it becomes obvious that the sum is 2 fruit. So there was a way to make this problem work. All you had to do is figure out what the objects had in common. And you've just laid the groundwork for common denominators. So now when we get to box L, the most important box of all, we put up that same problem that didn't make sense earlier, 1/2 plus 1/3. And I challenge the students and I say, we know this doesn't make sense to add them together because halves and thirds aren't the same thing. But boys and girls, what if you had to find a way to make it work? And there is a way, and we'll learn how to do it in our next lesson. And I actually have conducted this lesson with older students, with teenagers who are just entering high school, who had struggled with mathematics throughout elementary and middle school. And one year, when I did this lesson in the 9th grade, and we got to the part about covering this in the next lesson, one of my students, Ashley, goes, no, Dr. Palisoc, tell us now. So she was so intent on making sense of this problem that she didn't want to wait until the next day to figure it out. And when you can get to that point, it's like having a checkmate in math because students are no longer running away from math, but they're demanding to know how it works. So this lesson to me is a giant chess match. And do you remember my opening move in that chess match? What was my very first move? It was right there in box A. 1 apple plus 1 apple. And at the time, it seemed so trivial and so meaningless. But what I was really doing was thinking ahead, and I already knew what the winning move was going to be. So my strategy for this lesson was to remember that math is a human language. We can humanize math by putting the language back in there and including the units and including the words. And that way, once students have gotten a hold of the concept, now when you start abstracting it later on, it makes a whole lot more sense. So here's an overview again of that lesson. So you might be wondering, well, do you ever, during the lesson, talk about numerators and denominators? And absolutely, that's something that students need to know. So when we do talk about numerators and denominators, let me show you the way that I go about doing it so that it makes a lot more sense to students. And let me switch over to my document camera, which I've grown to love during online learning. Makes life so much easier. And let me pull this up. And here we go. So the very next page in the lesson, this is the actual apples plus apples lesson. When we get to the next page, we help students understand what numerators and denominators were, but we do it in a natural way that uses language to help them. So if you take a look at the term 3 apples, one part of this term is a number, and the other part is the name of the objects. So 3 would be the number. Apples is the name of the objects. Now take a look at 5 pencils. One part is a number, and one part is a name. 5 is the number. What's the name of the objects? The objects are called pencils. Oops. So these are the names. Now for the third one, look at 1/3. And here is a physical representation of that. So one part is the number, the other part is the name. 1 is the number, tells you how many you have. And the other part is the name. That is the name of the fraction. This, boys and girls, is called a third. Now when we write it like this, instead of spelling out 1/3, we write it in fraction notation. One part is still the number, and the other part is still the name. So 1 is the number, tells you how many you have. And boys and girls, what is the name? And they'll often want to say 3, but I remind them it's not pronounced 3, they're pronounced thirds. So third is the name of the fractional piece. And in California, a lot of my students speak Spanish, so I incorporate that into the lesson. So I say to write the Spanish words for number and name. So the Spanish word for number is número, and the Spanish word for name is nombre. And in number 6, it says to write the math words for each part of the fraction. Well, boys and girls, the number on top, that is called the numerator. And the number on the bottom, that is called the denominator, which seems like completely foreign words. Denominator. And in number 7, if you notice, it says circle the roots to show the connection between numero and numerator and nombre and denominator. The first one's pretty obvious. We can see that they both share the word numer. Numer in numero and numer in denominator or in numerator. And it turns out that numer is the Latin root for number. So numerator just means number. The second part's a little harder. Nombre and denominator. They don't look like they have any connection whatsoever. But if you look closely, you'll notice that nombre has nom, and denominator also has nom. And it turns out that the Latin root for nom, that means name in Latin. Let me write that down. So denominator, that just means name. So this is the number pieces involved, and that's the name of the fraction, the fractional piece that you're working with. So numerator and denominator simply mean number and name. And that's why when you see a fraction like 1/2 plus 1/3, you cannot add them together, not just because they don't have the same denominator, but because they don't have the same name. And that's why you cannot add them together. So When I explain what numerators and denominators mean to my students, I connect it to language so that I'm not just throwing these math terms around to them that don't make any sense to them, but I'm showing them what they actually mean, and then they're able to use that to help understand math a lot better. And then in subsequent lessons, we learn how to change names properly, just like we did when we changed 1 apple plus 1 banana into 1 fruit plus 1 fruit, which allowed us to complete that operation. So let me switch back to the other screen. So let me finish up this section here, and then we can open up the floor for questions. So I believe that if you humanize the math experience in this way, it makes math a lot more accessible. It turns students onto math a lot more than treating it as a completely abstract concept that students are not able to understand. And Sean mentioned that I used to work at the high school level as well. It's one of the schools that I started, actually. And I had the privilege of working with struggling students, teaching them lessons like this, and finally having them understand things that they had been totally confused about from elementary to middle school. And it really does have a human impact on them. So I'd like you to meet Joshlynn. This is one of the students at the high school. She was one of the students at the high school that I started. And I got her permission to share her story with you on Facebook. So you're gonna get a little peek into my Facebook account. And this is my account of her. It says, "Meet Joshlynn, one of my all-time favorite Synergy turnaround stories. Joshlynn came to Synergy for the first time as a 9th grader when we opened our new high school. Like many of Synergy's new students at the time, she struggled to pass algebra because she was missing a lot of basic math skills. This was a problem because if you can't pass algebra, you can't graduate from high school. I remember going into the classroom and working with Joshlynn and her classmates on a daily basis to get them caught up on the basics that they never mastered when they were younger. She was a student who always showed great appreciation for all the extra help she was receiving. As a result, she improved tremendously, passed algebra, and moved on to higher level math. She was also a student who got especially upset with me when she found out I was leaving Synergy in 2013. I remember her exact words to me, "Mr. Palisoc, you can't leave. You taught me my times tables." I was caught off guard that of all the things this teenager could have brought up, she specifically mentioned times tables. To us, it seems so trivial to mention learning times tables, but to Joshlynn, it was a matter of dignity because she couldn't handle the algebra coursework without it. I'm so proud of her because 4 years ago, you could have considered her just another inner city kid struggling to survive in school. But now you can call Joshlynn a senior class president and proud high school graduate on her way to a 4-year university in the fall. Mission accomplished. So that's one of my favorite stories to share. And Joshlynn is an example of how when math is inaccessible to students, it really does affect them at a human level. And it really was a matter of dignity. And when math finally started to make sense with her, it brought out the best in her. She was able to become senior class president and got accepted into a 4-year university. So that's an example of how when we humanize the math experience, it really does have an impact on people. So I'm going to go ahead and stop the presentation here. And there's so many more examples of how we can humanize the math experience. And I'd like to hand back the floor over to Sean to help moderate a discussion.
Wow, thank you, Randy. That's brilliant to hear a context of how we can take something like fractions and it can form the fundamental starting block, or as you say, something like timetables, and how that everything tends, especially with maths, tends to build on those fundamental foundation principles. Yeah, it's fantastic. And I know that there's, as you say, there are many types of other ways you can humanize maths or bring us a story behind it or look and examine the words. So I'm invited, I see there's a hand up already. And before I get to Sumi, I'd like to just remind you to just pop something if you have you can put your hand up as Sumi does, otherwise put something in the chat and hear the reactions and that we had from this presentation. Sumi, I don't know if you'd like to switch your camera on and chat.
Okay.
Nice to see.
I actually have a question for Randy. He was talking about how he changed the way he taught fractions and bringing more intuition into teaching, especially like in lower grades. Okay, so I'm from South Africa and we have primary school, high school, and then university. And we don't split our mathematics into like algebra and calculus. We just have one subject and it's called math. And we learn math from grade 1 till matric, and then you go, and if you want to do it in university, you do it. But my question is, do you think it's important to teach the intuition before the practical application or alongside it? Because I think maybe like in primary school, it would be more important to do intuition before, but then because at university level, we are able to do it in parallel, like not before, because that's how I did my math in first year. Like I was like I we didn't really do the intuition part, and like I was able to absorb the knowledge. So yeah, that's just my question.
Sure. So the question is the intuition versus the procedural aspects and so on. So I think both are important, and the kids benefit when you take both approaches. In terms of which to do first, usually I would say that the intuition part comes first and then the procedural part, but it actually depends on I think it depends on the topic. For some topics, it actually makes more sense to work on the procedural part first and work on that fluency, and then reintroduce it from an intuitive level. So in terms of which comes first, the intuition and conception versus the procedural, they're both important. Sometimes one comes before the others, but if you eventually end up doing both of them, I think it's a great benefit to students.
Thank you.
You're welcome.
Great. And then we have a couple of questions that have appeared in the chat. So let me read out the first one that I see, and then I'll hand it over to Randy. The question says, you said something earlier about students using their intuition to solve the maths question. I'm a university student and sometimes have trouble using my intuition in mathematics. How would you suggest an older student go about developing their intuition? That's from Layla.
Sure, absolutely. So I think a good example of this would be going back to calculus again. Again, it's something that I never learned when I was a young student because it was not offered at my high school. And when I went into that calculus class my first semester in college, it made absolutely no sense to me. And I left that class not even understanding what calculus is, even though I got a passing grade for it. I just knew how to find the answers, but I didn't know what it meant. So I ended up much later in life actually having to teach myself calculus. And one of the things that helped me learn it when I was older was using the same strategies that I insist my students use. Like when we're doing word problems, I insist that they include the units when they're doing their calculations, because that helps me keep track of what each of the numbers means, and it helps me spot mistakes much more easily. So to give you a specific example, let me share my document camera again. So here we go. So here in this example, this is a related rates problem in calculus. And I have two examples side by side, but one of them has a mistake in it. So we're supposed to find the rate of change of the area of the circle if the radius is growing at a rate of 3. And if you just look at this problem side by side, one of them has a mistake with them, but it's a little difficult to find out where that mistake occurred. So I'll leave it on for a few seconds so you can absorb it. But now if I take this very same problem and I put the units back in. So I'm going to put the units in, and I'm going to also color code the units. And when I do, the intuition behind the problem becomes a lot more clear, and you'll be much better able to spot the mistake. So here you can see that instead of just writing down 3 and 8, I included the units. So it's 3 meters per second and 3 centimeters per second and 8 centimeters. And when I do it this way, it becomes much more apparent where the error is. So if you take a close look, in this problem here, we're looking for an area. And I know area is presented in square units. So if you look here, this could be a reasonable answer because my final answer is in square units. But if you look on the other side, I'm looking for the area. And my final answer is not in square units, it's just in units, just centimeters. So this is not an area, this is a length. So when I do it this way, it's much more easy to spot my mistake. And I can tell that this is reasonable as an answer because it gave me an area. This is not reasonable as an answer because it's giving me a length. So by including the units in there, I can tell that something went wrong in this problem. But if I didn't include the units, it's much harder to figure out where that mistake happened. So if we go back to this example here, where did I go wrong? There's the 2 meters. The radius is 8 centimeters. Oh, I forgot to include the difference in the radius or the difference in time. So that would be the 8 centimeters here. So let me go put that in. Forgot to include the 8 centimeters. So here's 8 cent. Well, I'm sorry. I forgot to include the rate. So that is 3 centimeters per second. It's even helping me now. So that's 3 centimeters per second. Centimeters times centimeters give you square centimeters. 2 times 8 times 3 is not 16. That should actually be 48. So let me fix that. So now I have the correct solution of 48 pi square centimeters per second. And again, if I tried to solve this problem without the units in there and left the dimensional analysis until the end of the problem, I wouldn't have been able to spot the mistake that I made. But if I do the dimensional analysis within the problem, not only does it help make sure that I get the correct units, but it helps guide me with the intuition as well. So something as simple as insisting that students include the units, not only in their final answer, but during the calculations as well, is personally something that helped me when I was self-teaching myself how to do calculus later in life.
Wow, that's something, to be honest, as a maths teacher of over 20 years, I haven't given as much insight or thought about. I've often been one of those who said, leave it out, it's easier, and plonk on the centimeters at the end or whatever they're dealing with. But that gives a whole different dimension to it.
Yeah, and absolutely. And Sean, we're being experts at math, it's so intuitive for us that we can leave the units out as educated adults because we know what we're doing. But when you think about it from a novice who's learning it for the very first time, they don't have the intuition that we do. So that's why even though we can solve the problem without including the units, for a struggling student or someone who just can't get the intuition, something as simple as that can make all the difference. And hopefully they come to get to the level where they can solve it as well, even if the units are not included.
Okay, well, we've got some more questions that have popped up. And I see that there's a hand from Karen. Before I get to Karen, Anna's got a question. It says, Randy, how do you teach timetables? Can you teach a 17-year-old's 17 years old kid tables? So that's from Anna.
I would say it's never too late. It's always harder for sure, but it's never too late to learn them. And when students see the benefit of learning it, then they actually learn it a lot faster. So times table is something that is supposed to be taught in 3rd grade, at least in the US. And having taught middle school now for the past 4 years, it's something that I can attest that the students in the US do not come out of elementary school knowing their basic multiplication facts. So even though these past few years I've had 6th graders, I start off with the very first month of school is we are going to learn our basic times tables. So we spend the first month of school doing that. And then when we get to division and fractions, it really smooths the process. And it's really a benefit, even though it doesn't seem like a grade level standard since it's something covered in 3rd grade. Further down the road, it has a lot of long-term benefits. And for a 17-year-old, we've worked on teaching the times tables to students in high school, and they are able to learn it. One of the things that students don't realize is what multiplication means. So I know how to add something, like 7 plus 3, I just put them together. I know how to subtract something. So 7 minus 3 gives you 4. But it doesn't make into it a sense of how do you time something. Add is an action that I understand. Subtract is an action I understand. But times, how do you do that? So let me put my document camera on screen. Hold on 1 second. Here we go. So if you have a problem like 7 times 3, a lot of students don't realize that this means 7, it means 3 7 times. So this actually means 7 times.
We can't see your document camera at the moment.
Let me try one more time. Okay, are you able to see it now?
Yes, it's coming up.
Okay, perfect. So when students see a problem like 7 times 3, they often don't realize that it means 3 7 times. So this 7x really means 7 times 3. So it actually means 3 plus 3 plus 3 plus 3 plus 3 plus 3, 1, 2, 3, 4, 5, 6, plus 3, 7 times. So with a lot of high school students that I've worked with, they don't realize what times means. And it literally means 7 times. And when they realize that doing repeated addition is inconvenient, then they change their mindset and they say, you know what, I'd rather memorize it. 7 times 3 equals 21. So part of it is just getting over the mindset of not being able to learn it or not seeing the value in learning it. So it is still possible with older students. I've done it with students as old as 16 years old, but it does take time. And I think the first aspect of helping them to learn it is to help them get over that mindset that they can't learn it, if that makes sense. So, and it does take a little bit longer, but once they're willing to do so, then I think that's the first obstacle to overcome. And when I was a 3rd grade teacher, I also did come up with a system to help kids learn their multiplication facts a lot sooner. And we don't have time to discuss it now, but I'd be happy to direct you to different videos to show you how that system works. And one of my favorite cartoons actually is from Winnie the Pooh. So here's an image here, and I took a screenshot of this the other day. And this was at the end of the Adventures of Winnie the Pooh, where Christopher Robin was off to school, and the characters had no idea what school was. And it says that all they knew was it had something to do with twice times. So if I zoom in on the image here, you'll see they're trying to figure out what twice times are. So there's twice times 3, twice times 5, twice times 4. And they're not actually looking for twice times. They're looking for twice times. So if you look at the wording here, they misunderstood what twice times meant, and it actually meant twice times. They're actually learning the times tables. And the poor characters are trying to figure out what twice times means, and I love Eeyore's look especially. That's the look of confusion that we want to erase from our kids. And one of my favorite moments of that cartoon.
I think that just clarifies that it's not just about understand or knowing how to get to the answer. It's about having a deeper knowledge and knowing what is 3 times 7 all about before you learn it automatically. So that makes a lot more sense in how you approach it. Okay, great. I want to read Kathleen's comment before I pass over to Karen. I see Sumi's still got her hand up. I don't know. You keep that hand up if you want another question. And then Lawrence also has a question he's typed in. But Kathleen says, I like the idea of introducing the common denominator by introducing apples and pears. It also helps with the intro to algebra and like terms. I'm a great believer in defining the mathematical words. I know as well with nominator comes from the Latin root word of nominate or nominare, whatever it might be. And that comes in as well with the nominal interest rate as opposed to the effective interest rate. And these, if you study the root of words, it comes up time and time again. Okay, Karen, let's hear from you. If you want to switch your camera on, you're welcome.
Hi, Karen, welcome.
Hi, thank you very much. Oh, I enjoyed your presentation so much. Thank you. I have a comment. I am a psychologist and I do a lot of assessments, scholastic assessments and IQ assessments for kids who are struggling at school. And what I like about this method that you're using is that you realize when you work with kids a lot and they have to learn and do study methods that our brain likes familiar things. You need a frame of reference if you're going to be learning something new. And this is exactly what you tap into. It makes it familiar for them, it makes sense, and then it doesn't become something that they're scared of or new. Because it's always so interesting to me, I can hear a 3-year-old, say words like Tyrannosaurus Rex or these big, difficult words that because they know it from their favorite show, but then you have 12-year-olds who can't say denominator or understand what it is because it doesn't make sense to them. And as soon as you put it in a context that makes sense, then it's something they very easily remember. So that's what I love about this method. It makes it accessible in that way. And with a lot of the students, what I found with maths is that they struggle to concentrate and their working memory sort of doesn't kick in when they have to work out these sums. And some of them does have concentration difficulties, but some of them can't focus because their anxiety levels are so high. So you take the anxiety out of it with how you're teaching it because you make it familiar. And I love that about this method. And I wish that we could roll it out everywhere because I feel in South Africa, we don't teach either the kids have intuition when they go into school and they fly with maths or otherwise, and the others who don't have the intuition are often taught techniques and methods to make it easy for them, but they aren't taught to love it and have an intuition about it. So that I think is a bit lacking in our system and maybe in many countries because they have to get through the curriculum and have to understand the work. So techniques are taught, but the intuition and the love and the understanding is not really taught. So I love that about your method. Thank you.
Thank you, Karen. I appreciate it.
Great. Thanks for your perspective as well. It's good to hear where people are coming from. I have something from Lawrence. You're welcome to elaborate if you'd like, but let me read what you say. Hi, Randy. How would you apply this style of teaching and these techniques to make more abstract maths accessible, for example, with final year students?
I think the key to it is, and we have to accept that there is a lot of abstraction in math, and that's necessary. And a lot of things that we find, a lot of topics that we find in math, there's no other way to describe it than abstractly. But I think if we start with our students at a young age and get them to understand math at a conceptual level and use things like reintroducing the language aspect into math, that will get them a lot more comfortable with math. And by the time they get older, they're much more willing and are able to understand the abstract concepts. But if we start off with pure abstract too early when they're younger, then as they get older, they'll automatically have a dislike towards mathematics. So I think the key to that is starting them young, getting them to develop that math mindset early. And when we do get to abstraction, then it becomes a lot more easier to do that.
Hi, Randy. Yes, thank you for that. The reason that I'm very curious about this specifically is not too long ago, a friend in computer science heard about topology. And so I tried to explain what a topology is. And it was very difficult explaining abstractly. So I took a little time to think about how can I make this more accessible. And I started thinking a lot about like jars, like people putting different things in different jars, like the nuts in this jar and the apples in that basket and so on, and like splitting it up like that. And then I found a way to kind of correlate it towards topology, and that worked wonders. And then I had them explain it back to me like perfectly and make their own examples with other, maybe not fruits and things, but other worldly things. So with topology, I was able to do that, but that made me think, how would you be able to do it with other things? And your presentation reminded me now about that. So thank you for your wisdom.
Thank you. Thank you.
We have a very similar type of question. I think that oh, I've lost it now. It's coming here from Elizabeth. But it seems that you've answered part of this question as well, but it's good to see that it's a common idea that's coming through. I like the idea, Elizabeth says, of putting mathematics as a human language. Is it possible to use this technique to teach all mathematical subjects? Because some subjects seem to be more abstract. So it's also thinking about the abstract side of maths, which is more of a challenge to get across the understanding. But obviously, algebra is something that appears to be the most abstract. Yeah, I don't know if there's any more you'd like to add to that.
Well, I don't think that we can explain all of mathematics in the same way, but there's many different aspects of it that do make sense, that makes sense to teach that way. And I'll put my document camera back on. And here's an example, or a couple of examples actually. Okay, so document camera is back on. Let me know if it's not.
Yes.
So the whole apples plus apples concept. One apple plus one apple equals two apples. 1/3 plus 1/3 equals 2/3. It works for fractions. It works for physical objects. It also works for exponents. So here, 7x squared plus 2x squared, just like apples plus apples give you apples. X squared plus x squared gives you x squared. How many x squared? 9x squared. And if you think about this, what is a common mistake that students make when they first learn about adding exponents? Sometimes they think that x squared plus x squared gives you x to the 4th, which is incorrect. But if you start with apples plus apples, then they don't make that mistake. So that same concept can be applied to the idea of exponents. It can be used with place value as well. So billions plus billions give you billions, and that's why it's important to line up place values. And even when you're working with money, so here's a money example. Let's say this is $4.23 plus $1.34. That explains why it's important to line up the decimal points when you're adding decimals. Because if I slide it over, dollars can only go with dollars. Cents can only go with cents. What's the easiest way to make sure that dollars only go with dollars and cents go with cents? There you go, line up the decimal points. So that concept of apples plus apples has many different applications. It works with exponents, it works with place value, it works with money and decimals as well. And that's why when you see a problem like x squared plus y to the 4th, for example, they're not like terms. They don't have the same name. So that's why you cannot do a problem like this. So that lesson about apples plus apples is one of the most important lessons that I teach, because further down the line, when we learn about things like exponents, it still comes into play.
Great. Thanks for clarifying. Absolutely. I see we've got 5 minutes left, and I've got 3 questions. So, well, at this stage, or perhaps more, let me read through a couple, and then maybe you can answer as we go. From Anita, we have a question. It seems like a precursor for fruitful engagement is students feeling that the teacher is worth giving their attention to. How do you win over skeptical students, or how did you before your reputation grew? Actually, let me leave it at that, and then I'll move on to I think it's easier if we do one question at a time.
Sure. Great question, Anita. And I've had the privilege of teaching not only at the elementary school level, but at the middle school and high school level with struggling kids in the inner city of Los Angeles. And when they come to you as middle schoolers and high schoolers, they not only come to you low, but they come to you angry. So when you're working with middle school and high school students, especially who have fallen behind in math, there's a lot of cheerleading that goes on. Just as you say, it's a matter of gaining their trust, because in the past, math has been out to get them, and they feel like by you teaching them math, you're out to get them as well. So a lot of it is building that trust and being a cheerleader, and it takes some time. It's a lot easier when you're able to do it at the younger levels, but it does take some time. But if you keep it up, when they do start to trust you, then it does yield a lot of great results. And one of my favorite experiences was when I was helping teach a 9th grade algebra class. These were students in a tutorial class who had failed algebra at their previous middle schools. And one of the students, Ashley, we were working on some of these lessons, and she wasn't getting it. And she would say to me, Dr. Palisoc, I'm dumb. And I'd say to her, no, Ashley, you're not dumb. You just need practice. So sure enough, a couple of weeks later, she kept practicing at it, and she started to get it. So she says to me, Dr. Palisoc, I was dumb. And I said, no, Ashley, you are never dumb. All you needed was practice. And a couple of weeks later, I remember going back into the classroom, and the students were supposed to be independently working on their lessons. And I looked over to her, and she had a reading book, a chapter book that she was reading instead of doing her math work. And I said, Ashley, did you finish your work? And she said, uh-huh, without even looking up from her book. And I said, did you get everything correct? And she's all, uh-huh. And I said, how do you know? Because I never gave you the answer key to check your work. And she goes, Dr. Palisoc, I don't need a piece of paper to tell me that I'm right. So I just love that transformation of that student to go from someone who had no self-confidence in herself and was frustrated with math, slowly gaining their trust and being a cheerleader for them, and then having her declare that she believes in herself more than she believes in a piece of paper was one of the most gratifying moments for me that I still remember many years later.
Lovely story. That's what we all aspire to change students' frame of mind. Mm-hmm. Anita, you've got your camera on.
Just to say thank you. That was excellent. Thanks.
Thank you, Nidia.
Okay, I'm going to read the last 2 questions, and then I know that Michelle's got her hand up. So before we get to Michelle, let me read these 2 questions to you, because our time is drawing to an end soon. Excuse me if I get this name wrong, Sogofatso. The question is, if stigmas around mathematics are removed at an early age, it helps students to learn to their best of their ability, because they all believe they can do maths. What about older students? Because older students have an influence on the younger ones, and if the older students can overcome the stigmas, then they would be able to positively impact the younger ones. Okay, and then after that, a short question. What do you do with kids with dyscalculia?
Absolutely, both excellent comments, and I do agree. The mindset of math is passed down culturally through older siblings, for example. So I think that's a great point that was made there. And secondly, what do you do with kids who have dyscalculia? I often tell my kids that you have to be able to see the answer. So that's not just helpful to students with dyscalculia, but to students in general. So if they can see the answer to a problem, it helps them make a lot more sense. And I'll give you an example here. Pardon me as I keep switching back to my document camera. I use it constantly in class. So one of my students came to me with my former students came to me with a question, and he couldn't figure out 1/2 divided by 1/8. So he could do I reminded him about what the procedure was. So you multiply by the reciprocal. So here we can simplify. That's 1 and 4. 1 times 4 equals 4. 1 times 1 equals 1. Simplify that. The answer is 4. So we went through the steps, and he got the correct answer to this problem. And I asked him, do you know what that means? And he looked at it and said, I know how to get the answer, but I have no clue what it means. So I said, why don't we take a look at the model? So there's 1/2. There's the 1/8. And you have to be able to see the answer. And I'm looking at that model of 1/8, 1/2 and 1/8. And I don't see how that's a 4. So I suggested, why don't you pick up the pieces and start making them fit? So he picks them up. You start counting 1 time, 2 times, 3 times, 4 times. And it's at that moment that he goes, oh, I get it. It's the 4 means 4 times. This fits into this 4 times. So I had him actually write the sentence instead of just doing the calculations. Write the sentence and it'll make a whole lot more sense to you. 1/8 fits into 1/2 4 times. And that is why you need to know your times tables, because we learn it, we use it constantly. So I think having students see the answers to problems will help students not just with dyscalculia, but students in general.
Wow, that was a light bulb moment for me. I don't know how many others were there doing, wow, that hitting themselves on the head like I did, but that was brilliant. Let's ask Michelle to see what she's got on her mind.
Hi, thank you so much for the presentation. And I just think your method is absolutely brilliant. I mean, I am going into my 3rd year of engineering, and I don't think I've ever had a more eureka moment with mathematics than I have watching you teach me grade 5 fractions that I already knew. I have half a mind to go to my primary school on Monday morning and demand a refund. But just your method is so innovative and brilliant, but so simple and practical. And my question is, how long did it take you to come up with these methods? Was it a long time, or was it something that just came instinctively based on how you understood math?
Thank you for the compliments, by the way. I appreciate it, and I'm glad the presentation was helpful. For me, these methods came out organically over 23 years of teaching. I used to be someone who just used to teach by the book because I didn't know any better. And actually working with kids and realizing, you know what, this explanation makes absolutely no sense to the kids. And I know it doesn't make sense to the kids because it doesn't make sense to me either. So one of the things that I would consciously do is to think like a kid and put myself into their shoes. So when I'm designing lessons, I not only make sure that I understand it, but I imagine myself as an 8-year-old. Will I understand this lesson? And if it doesn't, if I can tell that it wouldn't make sense when I'm designing the lesson, then I come up with different ways to explain it. Using analogies and physical models is one of the ways that I help to do that. So it came about organically over the years, working with actual students.
And I think that's a great way for maths to come about organically and naturally, and without that stress that Anita was talking about, and Karen as well, that anxiety. So it's been a wonderful, rewarding experience just to hear your story and to hear other people contribute and hear their impact and their feedback about that. So thank you very much. Thanks for your time. and you're just starting your day in the United States. And I hope that it's a fantastic weekend. We're had a great, valuable moment of just understanding and listening to each other. So thank you.
Thank you, everyone. Thanks for joining.
Let's switch your cameras on. Let's see if you're bold enough to see those faces now. Very shy. There.
Can I quickly say something before everyone leaves?
Yes.
I just want to say, guys, we are on Instagram and we have a Twitter account. It's @SciMath1. Wisaarkhu is the name. So if you want to tweet us anything, if you think about something and you want to tweet us, you can tweet us, you can @ us. You can even DM us on Instagram and Twitter and Facebook. And you can share, and whenever the discussions will be up, the posters will be posted up. So you can even share it from there. So, yes.
Brilliant. Thank you, Sumi. Brilliant to get some marketing in there. And it's amazing to see the different stories that are told through Wisaarkhu. It's not just a stiff, rigid environment that sometimes people can think about.
Yeah, I agree.
We have people like Sumi there just liven it all up.
Thank you.
Great. Thanks, everybody. And thank you especially to Randy for your input.
Absolutely. Have a wonderful day, everyone.
Bye.
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 Thanks, Sean. That was